We will start the software. Here, it will connecting automatically. So here the communication is connected, and then we will first to scan the calibration board to scan the JMCB calibration board. I click it. It's scanning the board, and here we can see the message is here, and then we will setting our for the configuration setting is here we choose this output select. We choose the digital output. They can be select digital output 3 bytes, or digital output 2 bytes, or digital output 4 bytes. And here we can see the data sheet to for the difference. And here I will choose this digital output 3 bytes. And here is original voltage output, absolutely voltage output for wires. Here I choose uh, the original voltage output for wires, and here we can see this is the digital output. So here is 10%, and here is 90%. I will select this algorithm is 2 point in 1 temperature. So now I will save it. This is the difference between the digital output, the analog output for voltage, or something else. So I will save it. 然后 the second is the scan. Yes, the scan. This scan is to scan the transducer to see if the transducer is properly connected to the calibration board. It's so we can see here. Yes, okay, please. Here we can see this sensor we have already write the ID written, and this is the sensor ID. This sensor ID can be only written once, and now we'll go the setting. We'll do the auto configuration. Here we will first to generate a 0 point signal. I just change the rotatory, and now it's the 0 point, and I collect. Okay, finished. It shows finished, and then I change the rotatory of this simulating board, and then I to the full point, and I collect it. Okay, also finished. Here we can see the raw data are this. These are the raw data, and then I will do the calculation. Calculating is finished. Here the calculation is that this gain, polarity and offset are collected here because I have already operated it before. So this data is the same as I have done it before. And then I will save this configuration. Okay, I have saved it, and then I will change this rotatory to the 0 point, and I will collect the first point. It's 10% double collect. Yes, I have already operated before, so it shows that there are some data already existed, and then when I overwrite this data, so I will collect continue. Okay, and then I change this this transducer to the full point, and then this is 90% is for the full point. So I double click the full point, double click, and also it popped up that there's that already existed, and will you cover it? Yeah, I select yes, continue. and then this is uh, the data I collect for 0 point and full point. Then I will click calculate. Okay, calculate past. It's uh, collected, and I will do the error test. I collected the error test, and the screen will be changed to the error test screen. Here is the error test. Here we can see this is 90%. 90% is the full point. So here my transducer, the transducer is already at the full point. So I clicked error test. 90% it's okay. And then I change the transducer to 0 point, and then I change the expected value to 10%. And I also will click the error test. Okay, here we can see this is the result. It's past the full point and the full point and the 0 point. 0 point, the expected is 10%. This real is 9.983%. The deviation is very small. At this time, I can write the OTP. So yes, they will pop up. Will you confirm to write the OTP? And I clicked yes. Okay, the writing passed. Also, I can do a last test, but this time I will ignore this. So this is the operation for the digital output. I will finish the calibration.